चलो यहाँ से organic chemistry and we're going to start with isomerism. तो बिस्में ये कि starting with the first thing, एक सेकंड ना मैं ये अच्छा now starting with the first thing structural isomers. ये हमने किया था structural isomers and I told you कि you got structural isomers. Isomers were कि when you had the same molecular formula and different structures, that was specifically structural isomers. And what happened in structural isomers is कि when you have structural isomers, so the arrangement of the atoms is different. You have the same number of atoms, but they are arranged differently. So, for example, I did C2H4O2 and I drew all these structures. You're going to have different arrangement. There could be many different arrangements of C2H4O2. Structurally, they would be different. Their structural formulas would all be different. The arrangement of the atoms would be different. Or I explained to you that bending something or rotating something or twisting something does not make an isomer. For example, this molecule and this molecule are exactly the same because they have the same connections. Everything is exactly the same because this is not the exact shape of the molecule. The molecule looks different. So these two are exactly the same. Okay, moving on. Structural isomers will be divided into three parts. So there will be types of structural isomers, and you will be expected to draw any one of those types. तो अब types में क्या क्या आता है? Types of structural. So types of structural isomers. So what comes in types is that you have the first type, which is known as a chain or a branch isomer. बल्कि chain isomer, ठीक है? So it's a chain isomer. So what happens in a chain isomer is that if you have, let's say, a 5 carbon atom carboxylic acid, and it has all these OH groups attached. Now, the only thing that will happen in a chain isomer is that you're going to change the arrangement of the carbon chain. That's it. So only the arrangement of the carbon chain is going to change. So, for example, in this case, if you have 5 carbon atoms in a row, at the moment you've got a total of 5 carbon atoms in a single row. The only thing that's going to change is the arrangement of the carbon chain. So what you can have in this other isomer is you might have 4 carbon atoms in a row, and one of the carbon atom will be branched. You've changed the arrangement of the branches, or your baki H. Okay, so that is what is meant by chain isomers. So the focus is only on rearranging the carbon atoms. तो यहाँ पे बस instead now you've got a different arrangement of the carbon chain. That is it. अच्छा फिर इसी तरह next so you can have many different you can have another version of this one where this carbon could be over here. तो इसी को copy paste कर लेते हैं जल्दी से, ठीक है? So you could have another version of this and ये जो आपका carbon है इसको एक सेकंड हटा देते हैं. So this carbon can be substituted, the chain could be put somewhere else. ठीक है, H को ले आते हैं. So this carbon branch is now over here. So that's also तो ये आपकी branch यहाँ पे आ गया. That's also a chain isomer. Okay, so you could have another version of the same molecule. What you can have is chain isomer specifically. What you can have is you can have 3 carbon atoms in a straight line, and there's going to be double bond over OH. Or there's going to be 2 branches of carbon, one over here, the other one on the top. And there's going to be 3 H's with this one. 3 H's with this one and 3 H's with this one. So basically, again, you've got a total of 5 carbon atoms. But again, the arrangement of the carbon atoms is different. Okay. So you clear? What's a chain isomer? Is this clear?
Okay, sir.
As a second one.
Yes.
So there's a second one which is known as a second one is known as positional isomer. Okay, so there's the second version which is positional isomers. Now that's simple as well. All you have to do is like if I have a 5 carbon atom alcohol, so I've got an OH over here and the rest is all H atoms. Okay, positional isomers, so what you're going to do is you're just going to change the position of any group. You're not going to change the carbon atom arrangement. That will be chain isomers. What you'll simply do is you'll just keep changing the position of one of the functional groups or any group. Okay, so in this case, I guess you're going to change the OH positions. Okay, so I've drawn these 5 molecules, and all I'm going to do is, okay, the first one, the OH is at carbon number 1. Okay, in the second one, I'm going to put the OH on carbon number 2. Okay, so I'm going to put the OH over here. So it's at carbon number 2. And in the third one, I'm going to put the OH on carbon number 3. So one of them is, so that's carbon number 3. Now, one of them is pentin 1 all, the other one is pentin 2 all, and then you've got a pentin 3 all. Acha, fourth ke upar OH, can I put the OH on the fourth one? Will it make an isomer? Or on the fifth one?
No, sir.
Okay, वो isomer नहीं होगा. That's just going to be a flipped version of this molecule. Like just put it the other way around. It will still be pentin 2 all. Okay, it's not going to be pentin 4 all. So those are your positional isomers. Okay, so change the position of one of the functional groups. Okay, so that's, you can change the position of a double bond in a molecule and so on. So then there's a third type. The third type is a functional group isomer. So the third one is, okay, that's our functional group. So that's a functional group isomer. Now, what happens in a functional group isomer is that you just change the functional group. Now, a lot of molecules are basically a lot of your ये जो आपके homologous series हैं, they're basically functional group isomers of each other. For example, alkenes and cycloalkanes are, so if you have an alkane, which is C3H8, नहीं सॉरी, इसको alkene करते हैं. If I have an alkene like propene, ठीक है, and there's a double bond here, so this molecule will have an isomer which is going to be an alkane. That's cycloalkane. So this one will have two H's. It's saturated. All bonds are single bonds. So alkenes and cycloalkanes can be isomers of each other. So similarly, you will have other ones as well, like aldehydes and ketones. TK, you might have an aldehyde. Aldehyde is double bond O and H at the end. So these aldehydes can be isomers of ketones. The double bond O could be in the middle as well. It's still the same formula, same number of atoms. Everything is exactly the same. Because that's ketones and aldehydes. What else? You can have carboxylic acids and esters. They can be isomers of each other. A carboxylic acid is double bond O and OH at the end. Okay, there are three H's with this one. And an ester is where you have double bond O and O in the middle of the carbon chain. So double bond O and O coming in the middle of the chain. So a carboxylic acid, ethanoic acid can be an isomer of an ester. These two can be isomers of each other. So you कुछ examples हैं. So you can change the functional group as well. So you can do three things when you make an isomer, a structural isomer. You can change the skeletal formula, you can change the positional isomer, or you can change the functional group as well. Okay, is this clear?
सर तो पहले वाले को हम साइक्लो प्रोपेन कहेंगे या प्रोपीन कहेंगे?
Cyclopropane, alkane, it is an alkane, this one.
जी सर.
Single bond है, alkane है. ठीक है?
जी सर.
अच्छा, अब ये कि we can even do some questions, TK, just to give you an idea. So remember, we just did structural isomers at the moment. So let's do some questions, past paper questions. Usme. So related to isomers, एक second. So ये वाला होगा. So let's start with this one. So now ठीक है. Now over here he's saying what is the total number of different chloroethanes that are possible where n can be any integer from 1 to 6. Okay, so he's saying he find out how many different chloroethanes you can form where n could be any number from 1 to 6. So if n is 1, तो क्या formula होगा if n is 1? I mean, this is going to, if n is 1, so this is going to be C2H5Cl1, right? Is that clear?
जी सर.
अच्छा, तो उस केस में ना there's अच्छा, so in that case you just have one Cl, right? So, and the rest are all H atoms. Now, how many isomers are possible for this one? The first one, if n is equal to 1. कोई नहीं है ना, because if I put the Cl on the other one, it's still the same thing, right? Is that clear?
जी सर.
अच्छा, n can be any integer from 1 to 6. If n is 2, तो फिर क्या हो गया? If n is 2, it's going to be C2H4 and Cl2, right? So there's going to be 2 Cls, right? So,
जी सर.
अच्छा, so you can have 2 Cls and the rest are all H atoms. Ck dash is H. इसके how many isomers are possible for this? There's going to be another one, which is you might have 2 Cls on 2 separate atoms. Is that clear?
जी सर.
Yes.
So if n is equal to 2, there's going to be 2 structural isomers. Here n is equal to 3, that means C2H3 Cl3 as well. So that will give me how many? I can either have 3 Cls on the same carbon atom, and I can have 3 Hs, or what I can have is I can have 2 Cls on one carbon atom and 1 Cl on the other carbon atom. ठीक है, इसके अलावा तो कोई isomer possible नहीं ना, like if I have 3 Cls. Is that clear?
जी सर.
तो ये पहला वाला जो था 1
Yes.
Cl था, ये दोनों जो थे ना, this was 2 Cls, and then I had, if I have 3 Cls. अच्छा, what if I have 4 Cls? फिर क्या होगा? It's going to be 3 Cls on one and 1 Cl on the other one and 2 H's, right? Or there could be another version, which is, what's that going to be? It's going to be, okay, I can have 2 Cls on one carbon atom and 2 Cls on the, or the rest is H. ये दो होंगे ना, if I have 4 Cls, right?
जी सर.
5 Cl के साथ, if I
Yes.
have, if n is equal to 5 Cls will be just one isomer, right? It's just going to be 5 Cls, and there's going to be 1 H, right? Of n is equal to 6, so that means I'll have 0 hydrogens and I'll have 6 Cls. So that will just be one isomer as well. और उसकी different versions नहीं हो सकती. So how many total? That's 3 plus 2, that's 4. It's equal to 9. I've got 9 different chloroethanes. Is that clear?
जी सर.
अच्छा, फिर है कि next can be the both side. This one. Which pair of compounds have the same empirical formula? The first thing is ethane and ethene. That's alkanes. We can take ethane and ethene. That's C2H6. Ethene is C2H4. So they clearly don't have the same empirical formula. The ratio is 1:3 and this is 1:2. Achha, ethene and cyclohexane. So ethene is, so I'll draw both molecules. Ethene is double bond. So it's C2H4, right? CnH2n. And what's a cyclohexane? Cyclohexane is going to be 6 carbon atoms. Each one will have 2 hydrogens. So each one of them has 2 hydrogens. So that is C6 and H12. So remember this, that alkenes and cycloalkanes, they have the same general formula. So both of them is 1:2. It's so that, I mean, their empirical formulas are exactly the same. So alkenes and cycloalkanes always have the same empirical formula. They always have the same general formula as well. They have exactly the same ratio. So 2 or 3 dono, both of them are correct. Is that clear?
सर मुझे समझ नहीं आई.
The empirical formula is correct. This is cycloalkane, right?
जी सर.
और ये ethene है.
जी sir.
So what is the empirical formula for this?
C2H4.
The empirical formula. ये तो इसका formula है. What is the empirical formula?
सर किसका इथीन का ना?
हाँ.
ओके ओके हाँ समझ गया, मॉलिक्यूलर समझ गया. ओके सर.
ठीक है. Empirical formula 1:2 है ना. This is also 1:2.
जी सर.
So the empirical formulas are exactly the same. Just remember this: alkenes and cycloalkanes actually have the same formula. ठीक है. ये भी हमने पढ़ा भी था. ये लिख भी देते हैं कि but remember, for all of them, they all have exactly the same formula. Like an alkene and a cycloalkane will have, I mean, the reason they're isomers is because they have exactly the same formula. Aldehydes and ketones, they have exactly the same formula, but obviously they're two different functional groups. Carboxylic acid and esters, they also have exactly the same formula. ठीक है. अच्छा, अब इसी में बहुत सारे क्वेश्चन स्टीरियोस के होंगे. जस्ट अ सेकेंड. नहीं, cis-trans ही चल रहा है. अच्छा, for example, this one. अच्छा, let's try this one. अच्छा, he's saying how many alcohols, both structural and stereo, we haven't done stereo right now, can have the molecular formula C4H10O. So I'm just going to do structural first. C4, I need alcohols which have 4 carbon atoms. So how many alcohols are possible? So 4 carbon atoms, that's 1 OH, right? Over here. And there are 10 hydrogens. I mean, you can count the hydrogens. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the 10th one. So, अच्छा, isomers draw करते हैं ना. My preference is I don't draw hydrogens because उससे ना थोड़ी confused. I mean, it's easier to actually see the isomer without the hydrogen. वो याद रखना कि hydrogens आपको बराबर रखने हैं, ठीक है? अब मुझे बताओ what could be another isomer of this? And I'm just talking about
सर
structural
सेकंड
isomers.
कार्बन एटम के साथ OH.
ठीक है, so I can have the OH on the second carbon atom. ठीक है, so that's a positional isomer. Can I have another positional isomer?
नो सर.
ठीक है, that's not possible. अच्छा, और कौन सा isomer होगा फिर? अगर
सर ब्रांच्ड.
ठीक है, so I can have a chain or branch isomer. So instead of 4 carbon atoms, I can have 3 carbon atoms in a line and 1 carbon atom is branched, and I can put the OH over here. अब इसके बताओ positional isomers कितने होंगे?
सिर्फ एक और होगा.
और कहाँ पे? Where do I put the OH?
फर्स्ट यानी OH से अगर हम शुरू करते हैं फर्स्ट कार्बन एटम.
नहीं, राइट साइड से.
जी सर.
तो वो तो वही है ना. उसके अलावा कौन सा होगा? मतलब what positions can I change to get another structure?
You can put it on the second one.
ठीक है, so I can put it on the second one. ठीक है, so that is a positional isomer of the first one. What else? Where else can I put the OH? Can I change the position further? Keeping the same carbon structure, can I put it somewhere else?
I don't think so, sir, because the numbering will just remain the same.
And it's just going to be a flipped version. Like you've got 3 carbons on this side. You put the OH on any of these 3 carbon atoms, it would mean exactly the same thing. Okay, that will not result in an isomer. So you've got a total of, you can't change the carbon branch anymore. So you've got a total of 4 structural isomers, okay, in this molecule. That's how all crease. Just a second. So what is the number of isomers including cis-trans? So we're going to ignore cis-trans. Firstly, I'm going to talk about structural. Okay? C2H2 and Cl2. So there's 2 C's and there's 2 H's. So let's connect those 2 H's and the 2 Cl's. Now there's got to be a double bond in between, right? Achha, how many structural isomers are possible? So you got two CLs on one side, so you can, what you can do is you can have one CL on the left side and one CL on the right side. That's it. इसके अलावा तो कुछ नहीं बन सकता ना. I mean, these are the only two, because you just got two carbon atoms. You can't change the carbon branch, TK, because you just got two carbon atoms. And you can't change the position of the groups attached anymore, any further. So just two structural isomers, TK. Clear है?
जी सर.
Yes.
अच्छा, actually, it's the same question where n is 1 to 4, so we just did a similar question. So we'll do the rest of the questions. The rest of the questions also involve structural isomers, except that they also involve they're also involving the other type of isomers. So we'll try and cover that now, okay? वो जो other type of isomer है, what is that type? अच्छा, अब ये कि अच्छा, this is the isomer that you know of. Now there's another type of isomer, and that is, so that type is known as stereoisomer. Here, that type is known as stereoisomer. So what is the definition of a stereoisomer? So it's molecules having the same molecular formula, same molecular formula, and the same structural formula as well, which means that they're connected in exactly the same way. Which means they kind of look exactly the same. They're the same structural formula, but different different three-dimensional geometry. The molecule looks different. I mean, its actual shape is different. Okay, so this one is more about the shape of the molecule, not the connections. The connections are exactly the same. The shape is different. Here, one simple example to understand stereoisomers is it's your two hands. One simplest example is okay, एक second. ठीक है, so just उसी में मैं उसी image ले लूं. अच्छा, that one, this one. Okay, so it's just an example. Okay, this is one type of stereoisomer, or one understanding of stereoisomers. Your two hands, the connections are exactly the same, except that they're non-superimposable. You don't, I mean, they look different, basically because they're mirrored versions of each other. If there's a right glove for your right hand, that right glove will not fit your left hand, even though your left hand looks exactly the same, but it's a mirrored version. Okay, your fingers, the directions in which your fingers are pointing are different. Okay, your thumb is pointing right in one of your hands, it's pointing left in the other one. Okay, even if you try to rotate it, your direction of the fingers will switch, or the direction of the palm will switch. Okay, so no matter how you rotate your left hand, it's never going to look like your right hand. Okay, so idea clear है? What's a stereoisomer?
जी सर.
It looks exactly the same. The connections are exactly the same. Even the structural formula, the connections are same, except that it's just not the three-dimensional geometry is different. Okay, so the direction in which the fingers and different bonds are pointing, they're going to be different. So starting with the first one, okay, the first one is known as a geometric isomer. Okay, so that's number one. So that's known as a geometric isomer. So what's a geometric isomer? The first thing about geometric isomers is you need to understand. Firstly, you need to understand sp2 hybridization. Uh, it's got two conditions. One is that there should be a carbon double bond carbon that must be present. So it must be present. Now, carbon, remember, has 4 electrons. When carbon makes a double bond, it is sp2 hybridized. In simple terms, what it means is when carbon makes a double bond, right, in any molecule, it is kind of like this. It's when carbon makes a double bond, there's a double bond, then there are 2 single bonds. So whenever carbon makes a double bond, it's basically bonded to 3 atoms. What happens to carbon is that its molecule looks like this, that one of the electrons of carbon is being pulled by one atom, another electron is being pulled by some other atom. Okay, there's a third electron that's being attracted by a third atom. Here, that's being attracted by a third atom. And there's a fourth electron, which initially no one is interested in. So there's a fourth electron that's just buzzing around. Its negative charge distributed on the z-axis. Okay, so this is what carbon looks like when this is how carbon's 4 electrons actually look like. Okay, one electron bonding with one atom, one electron bonding and bonding with another atom. अच्छा, फिर आपके पास you've got another electron. So all 3 electrons bonding or getting attracted by some atom, 3 atoms. And the fourth electron is initially not doing anything. Okay? So that's known as sp2 hybridization, which means that 3 of its electrons, they change shape and they become sp2 hybridized orbitals. So you got sp2 and you got another sp2 and you get another sp2 hybrid orbital. Okay? This is what carbon looks like. So for geometric isomerism to happen, the essential thing is carbon must be sp2 hybridized. This is what a molecule of ethene will look like. Okay, one electron, तो मैं orbitals को ना बस dash से show कर रहा हूँ, ठीक है? So this is how a molecule of ethene would look like. That there's going to be, let's say, an H attracting one electron. There's a Cl that's attracting another electron, and let's say there's another carbon that's attracting the third electron. So carbon के ना 3 electrons, they're getting attracted. And the other carbon is also going to be sp2 hybridized. So it's going to be the same thing will be happening to it as well. That one electron getting attracted to, let's say, an H, another electron getting attracted to a Cl. So is तरह. And what happens in ethene is there's a fourth electron that is not doing anything. Okay, so there's a fourth electron. Okay, that's just roaming around. Okay, that's not doing. It's negative charge distributed on the z-axis. And this carbon will have exactly the same thing. ठीक है, it's going to have exactly the same thing. तो इसको उठा के उधर कॉपी कर लेते हैं. अच्छा ये. So in ethene, this is what happens. And उन्हें याद है clear है? राफे clear है? अहमद clear है?
सर
हाँ जी.
सर ये जो p ऑर्बिटल है ये पाई बॉन्ड नहीं बनाएगा?
हाँ, अब ये pi bond बनाएगा. ठीक है. What will happen is that the electrons which are not doing anything, they would eventually start to overlap. और जब वो overlap करेंगे, they will start overlapping above and below, and they would form so they would eventually end up forming a pi bond. Okay, so that's how a pi bond is formed, and that's your double bond. Okay, so this is what a molecule of ethene looks like. Okay, when it has a double bond. So ये clear है? This one.
जी सर.
हुनैत clear है? कुछ समझ आया? Ahmed, is this clear?
So I get the basic concepts, sir, but I haven't learned about the
ठीक है. So that's why I was.
orbitals, yes, sir.
ठीक है. So orbital is simply where the electron is located, right? It's the region where the electron is located. I mean, this lobe over here, that's where the electron is. It's negative charges, right? So you get the idea, right? That it's got 4 electrons, 1 electron getting pulled by one atom, 1 electron getting pulled by another atom, 1 electron getting pulled by the third atom. So that's like fan-shaped 120 degrees, right? So it's like a fan. The 4th electron is not doing anything. Is that clear?
Yes, sir.
The other carbon, it's got 4 electrons, 1 electron getting pulled, 1 electron getting pulled, 1 electron getting pulled. The 4th electron is not doing anything, right? Now what happens is that the fourth electrons, they start overlapping above and below because both atoms' nucleuses are attracting those electrons, right? मतलब दोनों atoms एक दूसरे के electrons को attract कर रहे हैं ना, one is attracting the other's electrons. So eventually what will happen is that this electron over here will get attracted by this nucleus, this electron over here will get attracted to this nucleus, and they'll start overlapping above and below. It's like two people fighting over electrons, right? So the electrons will kind of start overlapping above and below. Is that clear? And that's known as a pi bond. Okay. So I'll come back. So I just wanted to explain to you, like, why would it have stereoisomers? The reason it's going to have stereoisomers is that when it has a double bond, right, it's got a pi bond. If you have a molecule, remember electrons in a bond, molecules can rotate. I have to explain this as well. If you have single bonds, right, single bonds are like electrons in the middle, and there's a positive nucleus of one atom, there's a positive nucleus of another atom, and that atom has other electrons as well, so they would be bonded with, so they're going to be bonded with some other atom, right? So let's say there's H and there's C and there's Cl, and maybe another H, right? And this side as well. It's going to be bonded to different things. Like you might have 2 Cls and an H. Now, the point I'm trying to make is that rotation is possible around a single bond. So rotation is possible around a single bond is a sigma bond. I'll explain that later. But right now, the basic idea is rotation is possible around a single bond. What that means is if I start to rotate one of the sides, like a bicycle wheel, I start rotating the right side. This bond is not going to break because it doesn't matter whether this thing, I mean, think of it as a fan that's spinning, right? The nucleus is still there, the electrons are still there, so there's going to be attraction, there's going to be mutual attraction. This positive nucleus attracted to this electron, these electrons, shared electrons, are attracted to this positive nucleus. So the attraction will still be there. The bond will not break. Okay? So even if one of the sides of the molecule is rotating like a fan, okay, think of a fan that's sticking to a ceiling. If the fan rotates, its bonds with the roof or the ceiling are not going to break, right? So same thing happens over here. Like if this side is spinning around, nothing will happen to the force of attraction. Is that clear?
Yes.
जी sir.
Achha, but you can't spin things around a pi bond, because once you have a pi bond, you can't independently spin one side. Like, that's not possible. So you can't do that. Why can't you do that? Because it's kind of locked in place. Like, you would have to break the overlapping that's happening above and below. That's the only way. So you would have to break the double bond. Okay? So there was a single bond first, and then there's this double bond that's overlapping above and below. So you would have to get rid of that. Only then will independent rotation be possible. Is that clear?
जी sir.
Yes.
So rotation is restricted around it. So rotation, independent rotation is restricted. अच्छा, अब वहां पे ये कि on this side, it doesn't matter. The three-dimensional geometry keeps changing all the time. It's like a fan which is sticking to the ceiling. Its three-dimensional geometry keeps changing. If it's rotating, it's like the bonds are pointing in any direction, in any random direction. It doesn't really matter. So around sigma bonds or single bonds, because of independent rotation, the three-dimensional geometry keeps changing. It doesn't really matter in that case. But over here, the three-dimensional geometry does not change because the molecule is kind of locked in place. So is this clear that if this Cl is pointing downwards, then it will always be pointing downwards? Is that clear?
जी sir.
So अब इसमें ये होगा कि there's going to be another version of the same molecule. And that version is going to be, so remember, rotation is not possible. So the molecule is kind of locked in place. So there's going to be another version of the molecule. And in that version, what will happen is, बल्कि इस दोनों को साथ साथ ड्रॉ कर लेते हैं. अच्छा, in this other version, one of the sides will be flipped around, or कि Cl जो है ना ऊपर है and the H is pointing downwards. So there would be two different versions of the molecule. In one of the molecules, और इस पे अगर वो अच्छा, in the first one, the two Cls, both of them were pointing downwards. In the other one, or ये नहीं है कि it's not that one of the molecules is changing into another molecule. They're completely two different molecules. ठीक है? Because I told you that you can't just twist one side. So this वो बना ही इस तरह था. So the thing over here is that over here the Cl is pointing upwards. So if it is pointing upwards, then it will always be pointing upwards. Over here, if this Cl is pointing downwards, then it will always be pointing downwards. So the three-dimensional geometry of the two molecules will be different. Although the connections are exactly the same. The Cl is attached to the same carbon atom. The Cl is still attached to the same carbon atom. लेकिन उसकी जो direction है ना, that's different. Is this clear?
जी sir.
हो रहा है clear है?
So, sir, is there another one with both Cls on top, sir?
There could be, yes, but that will not be an isomer. I mean, that would be the same molecule. I mean, the same molecule if you just like if I just rotate it.
Mm-hmm.
So one of them is going to be called a cis version. So this is how, so the simpler version of this is going to be this one. Okay, it's you got double bonds, and there's an H and there's a Cl. And you've got a Cl, and over here you've got another one, which is so the Cls are pointing away from each other. The Cls are pointing in the same direction. Okay, so two different versions. One of them is going to be called cis. Cis is the one that where the molecule where the same type of groups, they point in the same direction. So this one is known as cis, and this one is known as trans. Cis means same side, and trans means opposite sides. Okay, so you got cis and you got trans versions of the molecule. So you clear के cis and trans?
जी सर.
Or इसमें ये कि just remember this: if you have a single bond, it doesn't really matter. The shape does not matter because the shape keeps on changing, because the sides are like kind of spinning around. So the geometry keeps changing. The first thing is that the carbon double bond carbon must be present, and the second requirement for this is that each carbon in the double bond must be bonded to two different groups.
So, sir, in this case, are any other functional groups involved, or is it just double bond Cs?
Nee, that's it. You just need a serial bond C. You could have any functional group apart from each carbon in serial bond C must be bonded to two different groups. I say if they are the same group, then obviously you won't have geometric isomerism. Like if I had an H over here as well at the bottom over here as well, then it wouldn't really matter. Like even if you turn it around and you make another molecule, that will still look exactly the same. Is that clear?
Mm-hmm. Yes.
तो आपको ना इस साइड पे भी you need two different groups. Over here you also need two different groups. Only then will, so on both sides you need two different groups. That is the only way geometric isomerism will be possible. So let's start with some questions. ठीक है कि we know what a geometric isomer is now. ठीक है इसके मैं angles वगैरह लिख लेता हूँ. It's the angles over here, बल्कि इस पे लिख लेते हैं. It's, I mean, the angles over here, that's 120 degrees, and it's trigonal planar, it's fan shaped. So it's trigonal planar. The other thing about ये जो आपका geometric isomerism है, the other thing about this is, बल्कि questions ही करते हैं direct. अच्छा, first one, let's say I've got a propene molecule. अच्छा, now when you a propene molecule is this thing, it's CH and it's double bond and CH2. So let's talk about propene first. The examples are, and the first one. Some examples of propene. Will propene form cis and trans isomers, geometric isomers? So you got a double bond और दूसरी conditions meet हो रही है कि नहीं हो रही? That each carbon must be bonded to two different groups.
जी सर.
So एक चीज याद रखना कि you'll be frequently asked to draw these. ठीक है? You'll be frequently asked to show the geometric isomers. Draw the cis and draw the. You're supposed to draw the trans version as well. So इसमें what you should do is remember कि draw the double bond. Or make sure double bond it's fan shaped, it's trigonal planar. So the shape of the molecule will look like this around. It's going to be 120 degrees. That's how. So make sure you draw this. Okay, you write all the things attached to it. Now this carbon over here is attached to two H's, right? So the carbon that's right at the end is attached to two H's. And the carbon over here is attached to one H. And on one side, it's got a CH3. अब बताओ, will it have a different, another version? मतलब वो conditions meet हो रही है कि you got a double bond, and I told you that both sides, both groups attached to it should be different. तो यहाँ पे तो ठीक है, it's different.
जी सर, लेकिन दूसरी साइड में नहीं है.
हाँ, लेकिन दूसरी साइड पे it's the same. So that means it will not. तो यहाँ पे you've got different groups. वहाँ पे नहीं है. You have the same. So you have the same groups. So this side you have the same groups. So even if there is another molecule where the H's are pointing in the opposite direction, it's still going to be the same thing, right? So no geometric isomers for this one. You clear your question?
जी सर.
Oh, that's clear.
Yes.
Achha, what if I had butene now? So so what if we had butene? That means I've got 4 carbon atoms. 2-ene means you got a double bond, right? And we've got 3 H's and we've got another H. And I've got 3 H's, right? So will this have cis-trans isomers? Your pehla question to wahi hai ki is there a double bond?
जी सर, हो सकता है.
Achha, so
Let's try some.
the first thing to wahi hai ki you got a double bond, right? Second thing is कि are the groups attached different or not? ठीक है, that's the वो second चीज है. तो यहाँ पे जो groups है ना, they are, both of them are different. वहाँ पे the groups that are attached, they're also different. ठीक है. So it will, I mean, the condition is, so I guess it will form cis-trans isomers because both sides, the groups that are attached are different. ठीक है. This one is attached to different groups and this one is attached to different groups as well. तो draw करने को किसने बताया था? I told you to draw the double bond first, fan shaped, and then attach things around it. So you got this one, H and CH3, and on this side you got H and CH3 as well. Abhi, which version have I made it? Is it a cis version or a trans version?
Yes, this version है.
The same side is cis. So the name of this molecule is actually cis-butene. It is butene, but it is, I mean, the exact shape is cis-butene. And similarly, you're going to have another one, which is trans-butene. It's going to have exactly the same connections. it's going to have exactly the same connections. Except एक फर्क होगा that the direction of these bonds or these groups is going to be different. The CH3 is pointing upwards and the H is pointing downwards. So instead of cis, this is actually a trans version. और ये याद रखना कि these two molecules are completely different molecules. It's not that one molecule is turning into another molecule. They're completely two different molecules. They're stereoisomers of each other. That they were made independently. They had the same structural formula. They had the same connections. Everything was exactly the same except for the direction of the bonds. एक में it's अगर उसको circle से mark भी कर लेते हैं. So in one of them, like the CH3s are pointing in the downward direction, and the other one the CH3s are pointing in the opposite direction. ठीक है, is this clear?
जी sir.
Yes.
अच्छा, so let's try questions. We know cis-trans now, ठीक है? So let's try questions about cis-trans. Questions में starting with we go start से करते हैं. अच्छा, let's try and find cis-trans questions. किसमें था? That's not cis-trans. अच्छा, this one. He's saying which compounds they show cis-trans isomerism. So you got butene. ये भी किया था. We just did butene. So I told you that in butene it will show cis-trans because the shape around the double bond is trigonal planar. So you're going to have a cis version, and you're going to have you're going to have the other version as well, which is the trans version, where the CH3 instead of pointing downwards is pointing upwards. I said but1ene, will it show cis-trans? But1 is 4 carbon atoms. So there's going to be 2 H's with this one. 1 H.
No sir, ये नहीं करेगा.
ठीक है, this one is probably not going to show because it's got a double bond, except it's got the same groups attached on one side. ठीक है, it's got the same groups attached on one side. On the other side, you've got 2 different groups. This carbon is attached to an H, and on the other side, it's got. So remember, you have to look at the whole thing as a group. But if you look at this carbon atom, it's attached to 2 things, an H, and it's got CH2, CH3 on the other side. What about 2-methyl propene? Propene is double bond. 2-methyl means 1 carbon on the second one. So you do have a double bond. This one will have 3 H's. This one will have 3 H's. This one will have 2 H's. So again, you've got a double bond, but will that double bond show cis-trans? है कि नहीं है?
सर यानी एक साइड में तो अच्छा एक सेकंड में
दोनों साइड्स पे 2 different groups attached होने चाहिए.
जी सर, लेकिन हम क्या CH3 को दूसरी तरफ नहीं जा सकते?
नहीं, वो इसकी बात कर रहे हैं. Remember ये चीज याद रखो कि when you're talking about stereoisomers, you don't change the structure. It's the same structure. उसकी arrangement change नहीं कर सकते. It's going to remain. I mean, we're not talking about structural isomers here. ठीक है, we are specifically talking about geometric cis-trans isomerism. Stereo के अंदर you don't change the connections. जैसा यहाँ पे ना, I mean, if you look at these 2 molecules, I'm not changing the connection. The CH3 is still attached to the same carbon atom. Over there, the CH3 is still attached to the same carbon atom. So I can't change the structure. Is that clear?
जी सर. सर थर्ड का वो पॉसिबल नहीं होगा.
ठीक है, क्योंकि इस साइड पे दोनों H है. So मतलब we same groups attached है. So it's not, I mean, the third one is not going to show cis-trans as well. Hunayat clear है? Ahmed clear है?
Yes.
So then I have this molecule. Saying how many structural and cis-trans are there for dichloropropene? Propene is where are the structural? Okay, he's saying I've got two CLs, right? So I've got two CLs. So those CLs are over here. There's an H and there's probably three H's with this one. So that's C3H4 and Cl2, right? So what first thing, I'm just going to focus on structural first. So I'm going to change the position of the CLs. Let's say I've got two CLs, but now one of them is over here and one of them is on this other carbon atom. This is three H's and there's probably going to be one H, just one H. बल्कि उस one H को ना मैं clearly show कर देता हूँ. So this one will have one H. So what else? So again, I've got propene and I've got one Cl over here and I can put the other Cl on the other extreme end. This one will have two H's. I've got an H and I've got another H. Then I have again propene. I've got two Cl, so I can have one Cl over here and I can put one Cl over here. And the rest is all H's. And I can have another positional isomer, which is that I can have two Cls on this end. And those are my four H's. ये clear है? This is just the I did not change. This is all positional isomers. I did not change two Cls over here, two Cls on extreme right and left. ठीक है, two Cls on adjacent carbon atoms, two Cls on the extreme one on the left, the one that's away from the double bond. So I've just changed the position. कोई और तरीका तो नहीं है position change करने का. I think I've tried all combinations. But is this part clear? Structural isomers, is that clear?
जी सर.
Yes.
अब इनमें से बताओ which one. So we're done with structural isomers, right? Now within these, how many will actually have geometric cis-trans isomers? उसके लिए what do you need? You need a double bond first thing. So you got a double bond, and the double bond must be bonded to two different groups. तो बताओ कि this one, first one, cis-trans or no cis-trans?
No cis-trans.
ठीक है, because वो दोनों sides पे Cl है, ठीक है. Second one, cis-trans or no cis-trans?
सर
Yes,
एक
we
पर
can.
Cl है और दूसरे पर CH2 है, तो नहीं होगा.
नहीं होगा. मैंने कहा था कि the carbon should be bonded to two different groups. So is it bonded to two different groups? It's a Cl and there's an H. And stand on this carbon atom. Is it bonded to two different groups? One side is H, the other side is this entire thing. So clear at both sides, you got two different groups. Is that clear?
जी सर, हाँ समझ गया.
So if I draw this around the double bond, it's going to look like this. The carbon on the right side, that's Cl and H. So it's got Cl on one side, it's got H on the other side. The carbon on the left of the double bond, it's got an H and it's got CH2Cl, right? So dono sides where it's two different groups. Which version is this one, cis or trans?
Cis है.
Okay, this is cis because the same side, right? And there's going to be another version, which is the trans version of this molecule. There's going to be another molecule with the same connections. Or यहाँ पे क्या होगा? The H, instead of pointing downwards, will be pointing one side of the molecule will be switched. So the Cl, instead of pointing upwards, still connected to the same atom, but it's pointing downwards now. So that's your trans version. So there's this other molecule which is an isomer, which is the trans isomer of this molecule. अच्छा आगे बताओ कि ये अगला वाला कि the third one, cis-trans or no cis-trans?
Sir, cis-trans.
Okay, it will have.
Yeah, we can.
So this one will have cis-trans. Achha, then what about the fourth one?
No cis-trans.
Okay, there's no cis-trans because this carbon is bonded to two H's. So अगर उसको three-dimensional draw भी करोगे ना, it's going to, even if you switch the side, it's going to still look the same. And the fourth one will also not have cis-trans because I said the fourth one will also not have cis-trans because even if you switch the side, it's still going to look exactly the same. ये clear है?
Yes.
जी sir.
तो बताओ कितने total isomers हैं? Well, all of them are.
7.
ठीक है. So what is going to happen is, this is how you're going to count. Okay, this is the first one. This is the second one. This is the third one. ये जिनको tick किया हुआ है ना, which are forming cis-trans, there are actually two molecules. I mean, this molecule is not one molecule. It's actually, there's this version and then there's this version. So you're going to count it as two molecules. There's going to be a cis version and then there's going to be a, or ye wala bhi, there's going to be a cis version of this and there's going to be a trans version of this. So when you're counting it, count it as two isomers. So first one, second, third, fourth, fifth, and sixth and seventh. So the answer is 7. Is that clear?
जी sir.
This molecule over here will have two versions. One of them is going to be cis, the other one is going to be trans. So this molecule को आपने एक count नहीं करना, it's going to be counted as two molecules, two separate molecules. One of them cis, the other one is trans. But that's clear? Am I clear?
So, sir, we don't count the structural ones for the cis and trans. We just count the cis and trans only.
Basically, you are counting the structural, but the structural has two versions. One is cis, the other one is trans.
Okay.
ठीक है? So, I mean, you are actually counting the structural, लेकिन उसको दो करके count कर रहे हो, ठीक है? अच्छा, और कर लेते हैं. Just this is chiral. So this. So we were on this molecule, right? We did this question. He's saying what is the number of isomers of C2H2Cl2 including cis-trans? So we did draw the structural isomers, right? So tell me which one of them is going to have cis-trans?
Sorry, the second one.
First one, that's not cis-trans, okay?
जी.
The second one is definitely cis-trans because both sides are different. So this molecule will be counted as two molecules. There's going to be a cis version and then there's going to be a. You need to draw. Which version is this one?
Cis है.
ठीक है. Trans में the Cl will be pointing upwards. So how many total isomers do you have? You have 3. One of them is this, and there are 2 of these. So you've got 3 isomers. Clear?
जी sir.
Achha, same one. This one might be. Achha, in which pair are the members cis and trans isomers of each other? Remember, the connections will be exactly the same. But for cis or trans, में ना वो direction of the bonds. 1 and 2, look at this carefully. 1 and 2, are they cis-trans isomers of each other?
जी sir.
ठीक है, मेरे ख्याल से वो है because I've got a double bond and I've got another double bond and the connections are exactly the same. And which one is cis over here? The CH3 is pointing upwards, same side. Over here, the CH3 is, one of them is pointing upwards, the other one is pointing. They're connected to the same atom, but so 1 and 2 is fine. I think that's fine. There's nothing wrong with that. So they're definitely cis and trans. What's wrong with 1 and 3? Like, what is wrong with 1 and 3? What one कौन सी version है? अच्छा, 1 and 3. Look at 1 and 3. Are they isomers of each other? First thing, tell me.
No, sir, they are same.
वो exactly same molecule है. It's just इसको अगर ना flip around करोगे ना या इसको rotate करो, let's say 180 degrees. If you rotate it, this you're going to get this molecule. वो ऊपर वाले ना नीचे आ जाएंगे. Like you pick it up and you rotate it 180 degrees, so it's going to look exactly the same. So they're actually the same molecule. और फिर ये कि fourth count नहीं होगा क्योंकि fourth is a structural isomer. It's not. Because fourth में ना both CH3s are bonded to the same atom, so that means you change the arrangement. So you can't change arrangements in cis-trans isomers. Clear है?
जी sir.
Yes.
अच्छा, अब इसमें ना there's another thing which is molecules can actually have more than one cis-trans. I mean the same molecule. ठीक है, they can have so they can have multiple cis-trans. अच्छा, ये जो mirrored version वाली बात थी ना, ये इसका इससे ताल्लुक नहीं है वैसे geometrics. I just wanted to explain to you what cis and trans are, or what stereochemistry is. ठीक है, that was just an example. एक सेकंड देना. अच्छा, अब आते हैं उसके ऊपर. If you have first one is symmetric molecules with multiple cis-trans. Unsymmetric, sorry. So if I have an unsymmetric molecule and I have multiple cis-trans arrangements, ठीक है, what so how many total geometric isomers will I have? So for example, I've got this molecule. It's got a double bond. It's got an H, H and Cl यहाँ पे. And I've got H, and I've got let's say a CH2. Okay, CH2 को छोड़ो. I've got another double bond over here, and it's got an H, and it's got H, and it's got a CH3. The first thing, looking at this molecule, will this molecule have cis and trans versions? I mean, it's got two double bonds. So if it's got two double, I mean this double bond, focus on this one, the first one.
जी sir, इसको sir.
ठीक है, the very first double bond. So both sides are different. H and Cl over here, there's H, and this entire thing, ठीक है, both sides are different. What about this other double bond? Will it have cis and trans? This side is different. और इसके ऊपर अगर आप खड़े हो गए ना, तो this side is also different. H and एक side पे ये. So that means both double bonds are actually making cis-trans arrangements, right?
जी sir.
So you can have cis-trans, you can have also cis-trans over here as well. So the question is, how many different arrangements will this molecule have? So I'm going to draw all the arrangements. So whenever you have a double bond, you have this thing. Okay, so you've got one double bond, and immediately that is attached to the other one as well. The other double bond also has the fan shape, okay, trigonal planar. So you got two double bonds. Okay, this is what the shape of the molecule will look like. Now the first one, okay, what if the first double bond over here, that's in the cis version? So that would mean if the first one is in a cis version, so the H's must be pointing, I mean the H over here, and there's going to be there's going to be an H over here or Cl यहाँ पे, right? हेलो सामने आवाज आ रही है?
जी सर, अब आ रही।
बीच में चली गई थी?
जी सर।
नहीं, बीच में आवाज कहाँ से कटी थी मेरी?
सर ये जहाँ से आपने अंडरलाइन किया हो।
अच्छा चलो ठीक है। खैर ये भी हैंग हुआ है, एक सेकंड। अच्छा यहाँ पे, अच्छा लेकिन क्लियर है कि अब नजर आ रहा है?
जी सर।
अच्छा अभी clear है कि you got a double bond and H and Cl attached, and there's an H attached on this one. ये कौन सी version? Which version have I drawn?
Cis.
Cis, sir.
ठीक है, that's the cis version. ठीक है। So that's my cis version. So the other one, I've got an H over here, so there's an H attached, and on the other one I've got an H and a CH3. ये कौन सी version draw की है?
Cis.
ठीक है, that's also cis. The carbons are. Actually, that's the first version. Okay, the first arrangement is a cis version, and the second arrangement is also cis. फिर और क्या हो सकता है? The molecule can have a different shape, where the first one could be cis, and the second one could be trans. Sorry, गलत वाले को कर दिया. So the molecule can, the first one will be cis, and the second one is going to be trans. Now, if I want to make it trans, so I would have to switch this around. In this molecule, the H is the one that's pointing upwards, and the CH3 is the one that's pointing. Still the same connections, but with the direction of the bonds, that's different. Is that clear?
जी सर।
Achha, then there's another version which is then there's going to be another version. In this other version, the first one could be trans. बल्कि दोनों trans हो सकते हैं, ठीक है? I mean, the first one could also be trans. To make the first one trans, I would have to take the Cl upwards. Okay, so that is going to be trans. And there could be a fourth version. एक और combination होगी. In this fourth version, the first one is trans, the second one is actually cis. So if I want to make it cis, to इसको वापस ले आओ. Bring the CST back up. So all four, there are actually 4 geometric isomers of this molecule. If it has 2 double bonds and both of them have a cis-trans arrangement, so in total the molecule will have 4 different geometric shapes. Okay, it's either going to be cis-cis, cis-trans, trans-trans, or trans-cis. Is this clear?
जी सर.
और वो दोनों double bonds का ना, you can make a combination of this. It's like you don't actually have to draw all of them. Okay, all you can do is all you have to do is just make a table like the first one is cis and the second one is cis. The first combination that the second one is trans. The first one is trans and the second one is या फिर आखिरी जो है ना, both of them are अच्छा, both of them are trans. Is that clear? अच्छा, ये clear है बात सारी?
जी सर.
Yes.
So मुझे बताओ, what if a molecule had 3 double bonds? So how many different geometric shapes will it have?
6.
16. Yeah.
देख लो कितनी combination. मतलब बना रहे तो I'll make a molecule. Cl, C double bond C, H, C, H, and then there is another double bond which has H and that's another H, and you got another double bond. Actually, this molecule I've got in this molecule I've got the first one is making cis-trans, okay? The second one is also making cis-trans. And the third one is also making cis-trans. How is the second one? Because the carbon over here is bonded to 2 different things. Like one side there's H, the other side is this whole thing. Either the carbon is bonded to an H and on the other side it's got this whole thing. So all of them are making cis-trans. So अब बताओ कितनी combinations बनेगी? Either all of them are cis. That's the first 3-dimensional shape. Or the first one, 2 are cis, and the last one is trans.
सर तो 16 हो जाएगा ना आखिर में.
8 होगा. मतलब कर लो ना, cis, trans. This one could be cis. Or you can have the last 2 could be trans. Or you can have abhi sari combination. What if the first one is trans? Well, इसी को copy कर लेते हैं कि there'll be 4 more combinations. अच्छा, there are going to be 4 more combinations. जो इधर से start हो जाएंगी. And you can get rid of the first one, which is you can make all the first ones trans. And trans. You clear?
जी सर.
Yes.
So there's 8. So there would be 8 geometric isomers for this one. Okay, so the idea yaad hai ki make sure you understand this idea that stereochemistry, it grows exponentially. Like agar ek molecule with 2 double bonds and 3, if you have 4, that's 2 to the power 6. So the formula is basically 2 to the power n. Okay, that's your formula. So number of geometric number of geometric isomers. That's a number of geometric isomers. वो ये कि if you have it's 2 to the power n, where n is the number of double bonds that make cis-trans isomers. So that makes cis-trans isomers. So idea, is this clear? You just need to know this formula. Is this clear?
जी सर.
Or
Yes.
अच्छा अब ये कि so that's 2 to the power n, right? और इसमें भी फिर एक और मसला है कि what if the molecule is symmetric? Symmetric means, so what if the molecule is symmetric? Symmetric means unsymmetric or symmetric. Unsymmetric means the molecule left and right side is different. I mean, I hope you understand what's symmetric. This is unsymmetric. Like there's a Cl on this side, there's a CH3 on the other side. Okay, so there is no symmetry in this molecule. Okay, the left and right side are different. Clear about what this is an unsymmetric molecule. Is that clear?
जी सर.
We use specifically in unsymmetric molecules. ठीक से होता. मेरी लाइट गई हुई है तो ये बंद हो जाएगा किसी भी टाइम. ठीक है, तो ये बस लास्ट चीज क्विकली कर लेते हैं कि अच्छा, what if the molecule is symmetric? If the molecule is symmetric, what will happen is कि left to right and right to left is exactly the same. Like we are symmetric, ठीक है, right and left right are exactly the same. So what happens is cis-trans and trans-cis would exactly be the same molecule. ठीक है, there would be no difference. कि पहला वाला cis हो, second फिर वो matter नहीं करेगा ना. Left and right and left are exactly the same. Like what if I had a Cl over here? So in that case, what will happen is that cis and trans and this, okay, first one trans ho, second one cis ho, or the first one is cis and the second one is trans, that they would represent exactly the same molecule. Is that clear?
जी सर.
So your number of isomers will actually decrease. Like the same molecule, everything is exactly the same, except if I make this molecule symmetric, then it will have 3 isomers. It will have cis-cis, it will have trans-trans. ये जो बीच वाले दो है ना, they would actually be exactly the same molecule. So you're going to have 3 isomers, geometric isomers. Same situation either. Okay, right now it's an unsymmetric molecule, but what if it is a symmetric molecule? So in that case, अगर यहाँ पे भी Cl होता, then it would be a symmetric molecule, and the left to right and right to left would exactly mean the same thing. So in that case, cis-cis trans will be exactly the same as trans-cis-cis. Is that clear? Or
जी सर.
cis-trans-trans will be exactly the same as trans-trans-cis. और कौन सा सेम हो जाएगा? बस ये दो, cis-trans-trans and trans-trans-cis. I mean, these two will be exactly the same. I'll just mark them. ठीक है. तो symmetric के अंदर, ठीक है, this is trans-cis-cis and cis-cis-trans. These two will be the same, and these two will be will be the same. So instead you're going to get 6 isomers, not 8. ठीक है, तो बस ये एक एंड में याद रखना कि if the molecule is symmetric, तो उनमें से ना two of the combinations would be exactly the same. Clear idea?
जी सर, तो इसका फॉर्मूला क्या होगा?
फॉर्मूला कोई नहीं होगा, बस उसमें अगर इतने ज्यादा तो आएगा भी, तो अगर 4 होने थे ना तो there would be 3. ठीक है, और अगर 8 होने थे then there would be 6. इसको बल्कि ड्रॉ करके ना देख भी लेना, बैटरी ना खत्म हो जाए, इसको ड्रॉ करके ना इफ यू मेक इट सिमेट्रिक, लाइक इंस्टेड ऑफ इस एंड पे ना CH3 हटा के Cl लगा दो, तो यू वुड नोटिस के cis-trans and trans-cis would actually become the same molecule. ठीक है, if you put a Cl over here, they're just rotated versions of each other. If I have a Cl over here, यहाँ पे Cl है और यहाँ पे Cl है, तो आप इस molecule को उठा के ना rotate करो, it would look exactly like this one. So basically they would exactly be the same molecule. The directions of the bonds will also be exactly the same. तो ये बस था. चलो ठीक है, ये हमारा geometric isomers जो है ना वो कंप्लीट हो गया. इसका बस ख्याल रखना, ठीक है. अनसिमेट्रिक में इट्स 2 पर n एंड इन सिमेट्रिक वो कम कर लेना, ठीक है. चलो ठीक है, कंटिन्यू करते हैं फिर.
ओके सर. ओके सर, अल्लाह हाफिज.
चलो ओके, ठीक है, अल्लाह हाफिज.
Thank you, sir.